When you are about to build and run your application on AWS, the first service most likely every one of you are going to use is the IAM, or the Identity Access Management. So in this video, we're going to introduce or review all those fundamental but important concepts from IAM, including the IAM policies, IAM roles, etc. We'll also run a quick demo to help you to quickly and seamlessly onboard it to AWS. So let's jump into it. Just a couple of steps to review and look at what you would normally use IAM. So which is always about who can access what. So who, including those are IAM principles, that's what we call. So essentially it refers to the people or applications, like the people from your organization who need to get access to your AWS environment, or those applications running on Lambda or EC2 who need to act on your behalf. On the right hand side, we also have the resources. Basically, those are the resources that are sitting in your AWS environment that need to be controlled for its access using the IAM. In the middle is the main part of the IAM, which is to control the permission for who can access what. And of course, sometimes you can define the conditions to really nail down the scenario for those principles to access your environment, so to make it more safer. The basic structure of the IAM policy language is as what we shown here, which is what we call the PARC, P-A-R-C. The P stands for the principal, and essentially the principal is basically the users who need to access your AWS environment, or the programmatic applications or machines that need to act on your behalf. As you can see here, the example is a IAM user, and you need to specify the AWS account ID associated with it. Then we come down to A. A means action. Essentially, it is what type of actions that this principal can act on top of the resource. So we have a fine-grained access control definition, and you need to look into those services that you're going to access and make sure what type of actions that's allowed to act on top of it. And then we have a resource. Resource basically are the AWS resources that you need to access to. And one of the pro tip here is that please don't use the $ account as a variable. So this is not allowed in the resource sector. You need to specify exactly for example, the account ID as what we shown here, and then to proceed. Last but not least is the condition, which is a really very important tool that can help us to set up the scenario and also to nail down the attack surface for the IAM access control. So let's take a look at what type of tools can grant your principal access to your AWS environment. There are two different options. The first one is what we call IAM principle-based policy, and the second one is the resource-based policy. So what does that mean? IAM principle policy basically refers to those policies that you can attach to the principles like users, groups, and roles. And of course, the recommendation here is that try to use the short-term roles as much as possible, right? Try to avoid using the IAM users if you can. So in this case, you can use the managed policy from AWS to start with, which is a more general way as you to when you're just about to start using AWS, and all those managed policy actually would be managed and maintained by AWS, and it's supposed to be very scalable, and you can use that across your multiple different accounts. And in some cases, if you need to run a POC, or if you need to define some of the ad hoc custom policy for your specific users or machines, then you will use the inline policies. And now let's take a look at the resource policies. Basically, these are the policies that you can attach to your resources, such as S3 buckets or an IAM role. So when using the S3 bucket policy, which is a very famous one, I believe many of us have already been using it. So it's a very good way to allow the cross-account access. And one of the pro tip here is that the IAM roles is the only principles within AWS that can be associated with both the IAM principles policies as well as the resource policies. So just keep in mind. The other aspect of the IAM, as we know, is that to restrict the access for your principals on the machine on the specific conditions. So what about the restrictions part? Let's look into that. When you need to restrict the access for your users, one thing that you can consider to use is the service control policies if you're already using the AWS organizations. So in this case, you can set up, you can use a similar IAM construct to build a policy, but basically you can use the policy to deny a specific actions at the organization level, right? So the things when you need to control the access boundary at the account level or the OU level as well as the organizational level, then you will consider to use the SCP. Then the next one is we will also have the IAM permission boundary, which is quite similar to the AWS service control policy in terms of its construct and setup. But basically, you will use the permission boundary of the IAM when you need to restrict a specific principal's access on AWS instead of restrict that access at the account, OU, or organization level. So the next one is you can also consider use VPC endpoint policies if you're already using the VPC endpoint. In this case, you can restrict what type of traffic that can access your resource sitting behind your VPC endpoint. And last but not least is the block public access, which is by name of it is one of the default setting of your S3 bucket. So the guidance here is that if your bucket doesn't need to be having the public access, try to use the BPA or block public access. Now it comes down to the IAM decision-making process. So as we know, by default, IAM is a deny. So if you don't have any allow statement, then it is a deny decision. But it will also look into if there is any explicit deny, and if it is, then it's also denied. Then it comes down to the next thing is to look at if our principal is a part of the organization, and also if the SCP, the service control policy, has been defined. Then the service control policy, if you're using it, you have to specify the allow, otherwise it's denied, right? Then assume, let's say you're using SCP and you also have the allow statement within the SCP. Cool. We'll look into the next thing. And again, as we just mentioned about the resource policy, if you're using it and then IAM will look into if there's an allow. If yes, then we need to look into the specific resource that you're trying to access. So for example, if you're using S3 bucket, and if your S3 bucket sitting in the same account as your principal, and then with the resource policy statement as the allow, then your principal will be able to access the S3 bucket, right? But it needs to be on a per resource basis, which means that different resource might have different behavior. So you need to look into the resource-based policy for its definition. Then, if you don't have a resource policy defined, but now it is the time for IAM to look at the principal and the principal-based identity policy. So if you're using the identity-based policy and you have to specify the allow, otherwise it's a denying. And if you have the allow in place, the next thing that IAM will look at is the permission boundary, as we mentioned before. So this permission boundary is to set the maximum permission that each single principal can have that is associated with this permission boundary. So you have to allow, otherwise it's a deny. Then the last thing the IAM will be looking at is the session policy. And if you have defined a session policy here, right? And if the session policy is allowed, then the final decision would be allow. Otherwise, it is a deny. So essentially, there might be some other bits and pieces of the details associated with the different resources. But hopefully, at high level, you understand how the IAM works based on this decision-making process. So now let's take a quick demo here. And what we are trying to do is now we have a Lambda function to showcase how can we actually define and fine-tune its IAM role for this Lambda function. and using the native service from AWS, which is what we call the IAM Access Analyzer. So the first step is that now we have a very basic Lambda function. It literally just returns a 200 success code. So we give it a test. So immediately it returned the 200 success code, which is as expected. With that in mind, let's switch to the configuration, and we scroll down to the permission tab. We can see this is the Lambda IAM role that we are using. And if we switch to the IAM service, we can see this role here, right? The test function role. And we scroll down, this literally is the permissions that's been included by this IAM role. Cool. So the next step is that basically we try to access the S3 bucket, and the way that we do it is that we try to list all the bucket names here. So we would change the code a little bit. If we go back to the code, I just copy some of the code from my code repo, and what I'm trying to do here is that I would do copy paste. So just quickly to showcase, what we're trying to do here is that we use the Lambda, the Python Portal 3 library, so we can define some of the Python function. So essentially what we're trying to do here is a very basic thing. We try to use the S3 list bucket function, and then to list all the S3 bucket, and then to print it out, right? So that's the first step. With that, we need to deploy the function, and we will try to give it a test. Cool, so now it's been deployed. Let's test the function execution. And after a couple seconds, so we actually have this status, the error code 500, which basically means that we don't have the required permission to access the bucket. So that's why we can't list all the bucket names, right? And by the way, this is as expected. We can basically execute multiple times for this action. So I would explain the reason why. Basically, behind the scene, because every single API calls that we made here will be captured by the CloudTrail, and that information can be used by the IAM Access Analyzer to create our latest permissions that's been required. So we just switch back to the IAM role, right? So the IAM role, this is the IAM role that's been used by our Lambda function. And I know some of you might say, hey, we just need the S3 list permission to make it work. But let's assume that we don't know what exactly the permission that we need. So what should we do? Instead of checking a lot of documentations or asking the ChatGPT or open or the other Gen AI type of activities. So what we can do here is that we basically can scroll down a little bit. As you can see here, we have a generate policy based on the CloudTrail event. So this feature is basically covered and supported by the IAM Access Analyzer. So we would click this create or generate policy, and we will say yes, please generate a new one. And what we need to specify here is that, hey, basically we need to tell the IAM Access Analyzer to say which CloudTrail event that we need to have the the checking to happen, and also the time period, right? So here let's just use the default time window, which is the last 1 day. And if we look at this, right, the CloudTrail to be analyzed, we actually have created a CloudTrail specifically for this use case, right? The general CloudTrail API trail. And this CloudTrail basically will capture all the management API activities that's happening, including the Lambda functions behaviors and activities that we just executed, such as trying to access the S3 bucket and list all the relevant bucket names. So now we have this required CloudTrail to provide IAM Access Analyzer the required visibility. Cool. And specify the regions. We basically want to in this case we select all the regions, because just in case we might have some cross-region activities that we want to cover. So let's keep it all regions for now. And then we will use an existing service role here. One thing to highlight that this role will be used by the IAM Access Analyzer to try to access the information that's needed. And in this case, we just need to make sure this role will have the permission to access the S3 bucket and also the CloudTrail. Cool. All right, so now we would click the generate policy, and it might take a couple minutes. All right, cool. Now you can see the status of the policy generation has been changed to success. Great. It essentially, in my case, it takes about 3 minutes. Okay, and the next, what we need to do is to click this button, View Generated Policy. Let's take a look at what the IAM Access Analyzer gives us. So basically, if you can see here, the action included in the generated policy, there are two things, right? One's the CloudWatch logs, which is expected, because at this part, when Lambda executed, right, it would create some of the logs and try to put it in the CloudWatch. So you need the actions to create the log streams. And also here, this is the main part, the S3. And here, the action used, we need to list all my buckets, right? Because from the CloudTrail, even though we have the 500 error code, but the CloudTrail will let the IAM Access Analyzer know that we trying to use this Lambda function to list all the S3 bucket. So that's why this activities has been captured, and this is required for the permissions to be created. And next, we can select, and this part basically based on these visibilities, right? As a developer, you can specify, hey, what type of actions that we actually need for allowing this Lambda function to do its job. And because you know what? Because for the CloudWatch logs, we understand that we already have the permission that's covered this activities. So we would leave it here. We don't necessarily need to specify any new activities to be created. But the key part is really about the S3. So we would use the list all my bucket actions. Let's click this drop-down box. We put it here, list all my buckets, right? And here, there's an option. Let's select that. This is exactly the permission that we need to unblock the Lambda function. And then we click next. Cool, everything looks good, right? And here, oh, actually, there's a error. And as you can see, right, let's just try to break it down. If you are not familiar with the IAM permissions, basically we have a different curly bracket, and these curly bracket are the OR in the OR relationship. So which means that first part, we have the allow effect. So the allow action is S3 list all bucket, and the resource specified to be OR. The star means OR, right? Okay, cool. And after the comma, and we have the second part. And if you look at this, it actually specifies the actions create the log stream. We basically think that, oh, okay, this part we don't necessarily need this permission. So I will just manually to delete that. Cool, we don't need that. And the last part is that we need to list all my buckets. Basically, this part is already covered by the first part. So I will just remove that as well. So I just basically add the one permission in it. You see? Now there's no red flag, which is good. I think we can proceed. And what we're trying to do again is try to add one permission as recommended by the IAM Access Analyzer. So we click next. And there's some generated policy names and descriptions. We'll keep it for now, just for the default option. And then we'll create and attach this policy. Great, all green. So if we go back to the Lambda function, just now we have a 500 error code. So what we're trying to do is that let's try to test again. 1, 2, 3, just a couple seconds. Boom. This time we got a 200 success code, and we actually can use this Lambda function to list all the bucket that we have within this account. And if we check back for the IAM page here, this is the IAM role that's being used by the Lambda function. And if you notice this part, the last part for the IAM Lambda function role, it actually there's a new policy that's been created as we just demonstrate, right? And using this policy, if I extend that a little bit, it actually included the S3 list all my bucket permissions. So this is really the key part to unblock our Lambda function. And I understand you might be thinking about, hey, what if my use case could be a bit more complex, right? And you might be calling the DynamoDB or the other services. So again, I think the same mechanism would play out here by the IAM Access Analyzer. So what you need to do is that essentially you need to follow the similar process, specify the IAM roles, and then you need to let the IAM Access Analyzer to understand which CloudTrail that you're trying to keep track of. All right. So just now we just showcased how to use the IAM Access Analyzer to help you to create the permissions that's been required by your principals. In this case, will be a Lambda function. Next, I would also like to show you how to utilize the Access Analyzer to help you to gradually narrow down the permissions of your IAM roles, so to align with list privilege security principles, right? To conduct your work, and also that will be the best way to secure your AWS environment. What we're trying to do here is that, again, we're looking at the same page for your IAM access for the Lambda functions, right? And then besides this permission tab, just look at this Access Advisor tab. If we click into it, it would direct us to some of the recommendation from the IAM Access Analyzer. In this case, you can see it actually provides you the visibility regarding what type of permissions that's been consumed over the past period of time. So as you can see here, we utilize the Amazon S3 permissions, and also we utilize the CloudWatch logs permissions, right? And then that's happened today. But some of the permissions that never been used are Bedrock. Amazon Bedrock basically is a managed service from AWS for the Gen AI and machine learning services, and also for the other machine learning services, including the comprehend and recognition, etc., etc. So if we look at the last access, it shows not access in this tracking period. Basically, you can modify or change the tracking period as you like. And basically that can provide you a lot of useful insight for whether or not you actually need these permissions. So in our case, apparently if I just go back to our Lambda function, we just need to check and list all the S3 bucket, and we don't necessarily need to access any of the AWS machine learning service. So that's why we can we can go back here. We can just try to delete the related permissions here, which is not used here. The name of it is SageMaker Canvas. So we can remove that. Cool. Because it just shows that over the last couple days, we haven't used this permission at all. So now let's give it a try. Let's just test our permissions. Yep. Cool. So the Lambda execution is still working as expected, and we got 200 success code as a reply, and it's been able to put out all the S3 bucket and list the bucket name here. Awesome. So that concludes our demo today. I hope you enjoyed this video, and if you find it useful, please give it a like and also subscribe to my channel. And feel free to comment on what other interesting topics that you might have on AWS, and that can help me to create the upcoming new contents for you guys. All right, bye for now.